Hello, I'm Patty Simpson with Simpson Math. Let's construct confidence intervals. So we're going to use our inferential statistics. We're going to infer about an entire population based upon a sample. In our first example, we have researchers want to estimate the mean monthly electricity bill in a large urban area using a simple random sample of 100 households. The researchers find the sample mean of $120.45. Assume the population standard deviation is known to be $15.50. Construct a 99.7% confidence interval for the mean monthly bill. So here, we'd like to be able to use a normal distribution to help us to find that confidence interval. And remember, in order to use normal, we need to meet three conditions. The first condition is that we have a simple random sample, that every sample has an equal chance of being chosen. And sure enough, we've collected a simple random sample. Secondly, our sample size has to be at least 30, or the data needs to come from a normally distributed data set. Here, our sample size is at least 30. 100 is at least 30. And then the third requirement is that the population standard deviation is known. And here, our population standard deviation is known to be $15.50. So we can use the normal curve. When we collect this 100 households and we find that sample mean, we know that sample mean is part of a sampling distribution that is in that normal shape. Now we want to create a confidence interval to say with 95% or 99.7% confidence that we know that the parameter mean, the population mean, falls within a certain range. So we've collected this sample mean, and we're going to infer from that sample that our population mean falls within this certain range. In order to find that confidence interval, the first thing we need to do is find our margin of error. And remember, to find the margin of error, we take our critical number, which that critical number is just the number of standard deviations out. So for 99.7%, that probability using that empirical rule for 99.7 is 3 standard deviations out. So our critical number here is 3. We're going to take our critical number and we're going to multiply it times the standard deviation. And that standard deviation is the standard deviation of the sampling distribution. So, we've collected this sample mean, and that sample mean is part of a sampling distribution, and the mean of that sampling distribution should be the same as the mean of the population. We saw that with the central limit theorem. So we're going to find the standard deviation of that sampling distribution. And the way we do that is we take our standard deviation of $15.50 and we divide it by the square root of our sample size of 100. So I'm going to take my 3 and my $15.50 divided by the square root of 100 is 10. So I'm taking my 3 times, we'll divide 1550 divided by 10, and I get $1.55. Multiply that out 3 standard deviations. So that tells me 1 standard deviation is out $1.55, but I want to go out 3 standard deviations. So I'm just going to multiply 3 times that 55. So 3 times 5 is 15, carry a 1. 3 times 5 is 15, plus my 1 is 16, carry my 1. 3 times 1 is 3, plus 1 makes 4. So there I have $4.65 is out 3 standard deviations. That's that distance from my mean out 3 standard deviations. I'm going to take that margin of error, I'm going to add it to my mean, and I'm going to subtract it from that sample mean. So first I'll do the subtraction. I'm going to take $120.45 and I'm going to subtract the $4.65. That's out 3 standard deviations. So a little bit of subtraction here. That's 119 gives me 14, which is 8, which is $115. That's going to be out 3 standard deviations below that mean. Then I'm going to go up 3 standard deviations from the mean. I'm going to take my margin of error and add it to my mean. So 5 and 5 is 10. That's 11. Carry 1 is 5. So $125.10. So my confidence interval is from $115.80 to $125.10 with 99.7% confidence level. I'm 99.7% confidence. I can say that the parameter mean, that population mean monthly electric bill, is somewhere between $115.80 and $125.10. I'm 99.7% confident that my parameter is going to be somewhere between those two numbers. Let's do another one. In order to estimate the number of calls to expect at a new suicide hotline, volunteers contact a random sample of 49 similar hotlines across the nation, and they find the sample mean is 42 calls per month. Construct a 95% confidence interval for the mean number of calls per month. Assume the population standard deviation is known to be 3.5 calls per month. So 3 characteristics to be able to use normal. Number 1, simple random sample, check. Number 2, sample size is at least 30, check. Number 3, we know the standard deviation for the population, check. So we can use that normal distribution. So again, this sample mean of 42 is part of this sampling distribution. And we know the mean of that sampling distribution is going to be the same as the mean of our population. So we're going to construct a 95% confidence interval. So this time that 95% tells me that my critical number is 2. I'm going out 2 standard deviations. So that fancy notation that we saw for our critical number, this just means the critical number is 2. We're going to go out 2 standard deviations, and it's because of that 95%. I'm first going to find my margin of error. To find my margin of error, I take that critical number and I multiply it by my standard deviation. But remember, I'm not dealing with the standard deviation of the population. I'm talking about the standard deviation of this sampling distribution. And the standard deviation of that sampling distribution is the standard deviation from our population divided by the square root of our sample size. So here I have 2 times, 3.5 square root of 49 is 7. So we got 2 times 3.5 divided by 7. 35 divided by 7 would be 5. The decimal stays, so I've got 0.5. So 2 times 0.5, 2 halves, 2 times 0.5 equals 1 whole. So my margin of error is 1 unit, is 1 call. And that's out 2 standard deviations. So now to find my confidence interval, what I do is I take that mean and I subtract that 1. And I take the mean and I add the 1. So think about that sampling distribution. That mean is part of a sampling distribution. And I know out 2 standard deviations is out here to 43. Back 2 standard deviations is 41. with 95% confidence level, I can say that the parameter, the population average number of calls that we get is between 41 and 43. So that's what that confidence interval does for us. It helps us to infer about the entire population when we have a sample mean. And we can do that because that sample mean is a nice unbiased estimator. Math Made Simple is some math. Thanks for watching.